Hello, everybody. Thank you for coming today, and welcome to our Planet Cassandra meetup. This is a monthly meeting, and this time we're gonna talk about ACID transaction in Apache Cassandra, and we have Patrick, and we're gonna let's hear from you, Patrick. And without further ado, the floor is yours. We are all excited to see what's going on.
Yeah, me too. Oh, wait. I showed up thinking like, oh, is there an update on acid transactions? Yes, there is. But this is funny because and hello everyone, I'm Patrick McFadin if you don't know me. I'm on the Cassandra PMC. I also work at DataStax, an IBM company. And been working on Cassandra. Oh, this is my 13th year of working on Cassandra. That's a long time. Um, but I'm excited because we're starting to talk about shit that I wanted like 10 years ago, like asset transactions. Here we are. And, today is meant to be a bit of an insider. I think what's cool is this global meetup that this is, and I really appreciate this, like what this is, because this is a good, nice, independent event. But you're also kind of insiders. You probably are on the dev list. You're probably understand how the Cassandra project works a bit more. So I'm going to speak at that level. I wouldn't if I'm just doing a live stream and I do a lot of these where I'm just talking to anybody who might even remotely be interested in Cassandra, I get a little more basic. But this one, I'm going to talk to you like, hey, you've been using Cassandra, you know what's up, you know how things work in the project. So a couple of things here is today's going to be an update, and I know this is like every time I talk to a Cassandra user, it's like as soon as ACID transactions comes up, that's all they want to talk about, right? um, and I think too, if you if you have a question or whatever, I don't know if you have a chat or whatever you're going to do, but maybe we can just wait until the end, I guess. So a couple of things to start. If you hadn't heard, we're calling the next version of Cassandra Cassandra 6. That was a that was a really weird discussion on the mailing list, but this is what we're going to do. Um, we were calling it 5.1, but when we realized that there's just going to be so many breaking changes in 5.1 from 5 that we said let's make this 6. Um, the thing that makes 6 probably more of a reality or importance is the fact that we're using the transactional cluster metadata, which I will not be talking about here. But that changes the way Cassandra operates, and from an operator standpoint, it gives you a ton of changes. They're very positive, but it's a big, huge lift. Not just ACID transactions, but all the stuff that makes it happen. Okay, so this is what everyone asks. Are we there yet? We have been talking about ACID transactions, I think, for 5 years, and I I'm kind of unapologetic about it at this point because I'm like, what? Are you expecting that to be an easy feature? It shouldn't be an easy feature. If it was, I wouldn't trust it. And the Accord protocol, and this is another thing that we keep talking about, is Accord. And this is what everyone should know. Let's stop talking about Accord. Accord is the protocol, the consensus protocol behind the scenes. Let's start talking about it in terms of a database. If you notice in my slide here, I said, hey, ACID transactions. Because that's what everyone in the world thinks about. ACID transactions. Not if I say, hey, Accord is coming to Cassandra, no one's going to know what that means except for the insiders here. So we're talking about this. So it's been a long time coming. Here's the update as of today. This is the big. So the way I'm going to structure this, I'm going to give you the update as of today, and then I'm going to walk through some things like some call to action type stuff, like things we need you to do as a community to help us get there. And then I'm going to break into some just some develop. If you don't know much about what's going on with ACID transactions, I have some just a little brief overview of what it means for developers, and then I have a brief overview of what it means for operators, people running clusters. This will be a good opportunity for you to learn about what it is, like what are we getting with this besides ACID transactions, and if this is not new to you, then you can feel free to drop off towards the end. But I'm trying to preload everything in the beginning with the new stuff, and then I'm going to give you some updates along the way. Okay, so as of today, so Accord and TCM, where they were living in a CEP15 branch on the project, they are now merged into Trunk, and there's still ongoing things that are being merged slowly in, but the merge is complete from CEP15. That was the separate trunk or separate branch that was being managed for like over a year. That is now merged. Awesome. So what does that mean when it's merged in a trunk? Well, if you do a git pull on trunk, then and you do an ant build, you'll have it. Ta-da! I will show you a way easier way to use this in a minute. If you love building Cassandra, then go for it. If you do on trunk, then you'll have ACID transactions in there. And the important thing that I mentioned was that the next version will be 6.0. That's what we're driving towards right now. So all the new changes, all the updates, everything, they will not be happening in a separate branch. They will be happening in trunk. So if you refresh trunk all the time, or you're one of those psychopaths out there that run your production systems on trunk, and I know you exist, just know that that's what's going on. um, and so the acid and TCM. Now, I have to keep reiterating, TCM is probably a bigger deal than Accord in the long run, just because of how it so fundamentally changes the way we run Cassandra clusters. And I know I'm like merging two things together here, but and we should probably have you all should have somebody talking about TCM here shortly. Maybe that'll be me, but TCM is changing the way we run clusters, meaning that transactional part of running a cluster, instead of having gossip just be like YOLOing changes throughout the entire cluster, um, which has worked well. But gossip protocol, the gossip protocol itself, is non-deterministic. It kind of floats through, like big changes floats, and there's no such thing as a gossip storm. Stop saying that. But there is delay, and it's not. So think things like when you change ranges on your cluster, you make schema changes. How many of you have had a schema change issue where you've had like a schema mismatch? That's thanks to gossip and the way the gossip works. And gossip has been on the plate forever for let's fix this. And so TCM is a big deal because that means that every change to the cluster will be a transaction. And so these things work together. All in all, I think I mistakenly almost merged or PR from branch into trunk. And I know this is how I know this number, but there was 18,000, I think 18,000 lines that were changed. It was a lot. I didn't. Benedict got in front of it and he's like, "No, don't do that. Oh, stop." So that's why I knew that. But it's a lot of code, and so we're in this mode right now of test break fix. We let's just big hand round of applause for the Apple team. This is who's doing all the work. If you see like David Capwell in the Accord, the Cassandra Accord Apache channel, he's really just running interference all the time. But the latest is that this is what's happening right now. Is that this is test break fix, test break fix. You'll know that from previous years with Cassandra, we've really been adamant about correctness, and so we have fuzz testing with Harry and loss testing, and we have a test suite. This is now challenging that test suite and Charlie challenging what acid is. And yeah, there's a lot of bugs. But what was cool is a couple maybe this week or earlier or late last week, David did start posting some benchmarks and starting to show up. Yeah, in comparison to Paxos V2, it's a little faster in some cases, which is great. And Paxos V2 is pretty fast. Side note, if you're using 4.1, you should upgrade to Paxos V2. Much better than Paxos V1. That's for lightweight transactions. But this is what's starting to emerge is, hey, we're doing performance testing. Hey, we're doing more in-depth loss tests, and all the different testing, the fuzz testing, and putting it into like against production workloads. How does this look? And this is what really we need your help at is and here's one of the images I had the Google Gemini create me an image based on my slide. I'm having fun with this. Wait until you see some of these. I just left them because they're just funny. I said Cassandra time to get serious. This is what it came up with. Classic. Not my artist, the guy who makes my t-shirts. He's not that guy. Johnny Diaz, no. um, so this is what we need. We need your help. We need we need you to use it. We need you to go out and look at it. And here's what I don't want is we release a beta or an RC and you first time you use it and you're like, oh, I can't use this because of the syntax. This is not the time to be bringing that up. And you have every opportunity right now to do it. I know I'm giving you like the dad voice here, like you kids, you take care of your ACID transactions. But um, we can do this. And I'm going to show you how you can do it. It's super easy. I made this really easy for you. You have no excuses. So the syntax feedback, huge. Use case feedback, try it out on some things that you might consider for ACID transaction with Cassandra. See how it works. This is where, when you start using it, is when you start finding things. I even have an example that I did. And then deployment. Try it out. Try a clean install. See what happens whenever you just brand new cluster, bring it up. What happens? And if you can try it up, do like an upgrade, do not do this in production, but if you can restore or fork off a cluster and try to do an upgrade and see what happens and migrate some tables. And I'll show you how to do the migration. These are the things. Now is the time to start doing this. And as responsible, engaged community members, this is the best thing you can be doing to get there. Why? Is because this is what makes it go faster. This is what I always say, like, why? We need it. We need it. And speed. Right now, if you want ACID transactions in production, the more eyes we have testing it, the better. Because right now, I mean, we have a small group of people that are testing this. And I'm going to shut my window. Ugh. It's summer here, or it's almost summer here in Northern California, and all the leaf blowers are out. So just going to close that off. The speed is what, I mean, you're like, hey, is it here yet? Hey, we can get there faster if we work together. And I think this is good. And I do say this with, I mean, no reservations. We're shaping the project for the next 10 years. At the next Apache conference in Minneapolis, I think it's Minneapolis. Yes. I'm going to be giving a talk about imagining the next 10 years of Cassandra. And it's all being enabled by what we're doing today. It will greatly change what we've done. CQL 10 years ago greatly changed the way we use Cassandra. This is a new version of Cassandra, a new paradigm, new world ahead of us. So, yeah. So, as leading by example, one of the things I did was I started using it quite a bit, testing, trying new use cases, and I found something. I found out this thing that I highlighted in yellow. I was like, this looks like it would be really helpful. And what it was I just threw it out there. Like, I wonder if you could do this, because there's, and we'll get into the syntax a little bit, but
so
yeah,
Patrick,
Rahul?
just to check, we're seeing the why then, like feedback, speed, preparation slide. Is that what you want to show us, or do you want to show something else?
I changed
This
it.
is
No,
what
I
did I
see
find?
the what did I
Yeah,
find
I see
slide.
it
I see
too.
it the one he's on.
Rahul, are you on your 56K dial-up modem still?
Okay, I
I'm just
apologize.
checking.
I want to make sure. All right, I'm sorry.
That's all right. And I always want to be QA'd. And it kind of fits in with the theme here. It's like, see something, say something. Let's make sure it's all good together. Rahul, super community. All right. Um, this is what I found was I was playing around, and part of the, and we'll go into the syntax in a minute, but I was like, wouldn't it be great if I could create, because there's a way that you can assign variables inside of a transaction. I'm like, I'd like to just create a UUID like as a reference, and then timestamp, so that everything has the exact same timestamp and reference UUID. I think that would be really cool, right? I tried this out, and oh, you blew up completely in my face. So I decided that I'm going to fix that. So I started working on it. I'm adding this syntax right now to Accord, and I just need to finish it. But it's really, it's not a big trick. I changed the grammar to allow this. It's just adding it as, you can do aliases, but I didn't find this until I started using it and said, hey, this would be really useful. And now's the time to be doing this, not after 1.0 is out, right? And so I'm giving you an example. And I think, and also, you probably might find this is interesting and useful. And this is going to change things because of the way transactions work. There's things that happen inside of a transaction block that are isolated and need to then have, the ACID qualities. So especially this isolation. And when we do that, it opens up a bunch of different ideas and different use cases and things like that. So this is my encouragement. Go out there and use it. I really hope that I'm not the only one who finds the missing things in our syntax. I know there's probably a lot more. So I'm just going to do that. Okay, I'm going to stop there. That's the update part. Now I'm going to show you how you can start using it today. And this is also important because this is good for you. Like I know everyone has tons of time. We just heard from Rahul how he has all this time on his hand. But the thing that I'm trying to create here is something that you have, like I said, very few excuses to not use it. So I'm gonna keep going here. Okay, so I created a repo called Awesome Accord that just goes into everything around that protocol. And this you can use the QR code here, but inside of that repo, there's a few things. First of all, the most important thing is links to getting to I created a Docker image. Matter of fact, I just updated it yesterday with what's in trunk. I did a trunk pull, did a Docker build, and I put it up on Docker Hub. So you can do a Docker pull, and I'll show you the command here in a minute. But that this repo will show you how to do that, and then there's a bunch of examples for you to try. It's really simple. So this is pre-production code. There's going to be some bugs, and there are missing features. So just I don't think anyone here was expecting much. And I even put up a little thing here. So if you have questions, I don't know if everyone's going to use this or not, but it's out there. But you have two choices. You can do it locally with Docker. And then John Haddad was really cool and helped me set up his EasyCas lab, which lets you set it up really easy on a lab, hence the name. It lets you deploy a cluster really quickly into Amazon. It's a command line tool. It really is easy, so it's a very well named project. But if you want to set up like a 3-node cluster in Amazon real quick to try things out, you can run the CAS stress against it. Do different things. So if you want to do cloud, you want to do local, you have options here. The local option is the one that you probably want to use just because it's quick and easy. I mean, you could do this right now, Docker pull, McFadin Cassandra Accord, and depending on your internet speed, it'll be ready to go in a few minutes. Those commands are all in the repo. And when you run the CQLSH, you are in a command line, you have a command line access to an Accord enabled cluster. So it will run ACID transactions. If you find any bugs, let me know. But it's pretty simple. And I believe Aaron is going to be using this for some stuff that he'll be doing soon too. So it's just meant to be easy. And you don't have to go build Cassandra. Building Cassandra isn't always tough, but it's not. I mean, there's a lot of commands and a lot of setup. You have to get ant and everything else going and get the right JDK 17 now. So you just don't have to do any of that. And inside this repo, I have some examples. There's some banking examples, which everybody wants to talk about. Like, oh, now I can do banking. Yes, you can. Inventory management, which inventory management is a mask that's the use case, but the real thing that's really, really cool that I'm so excited about with ACID transaction is the syntax for updates that allows us to increment, decrement, do all these things, and then even put limits. You can go to 0 in a contended workload. Like for instance, inventory, I only have 100 of these things. All right, you'll only sell 100 of these things, not 101 by mistake. This is like going to change some things. There's so many retail use cases. Think of every retail website that has Cassandra behind it, and there are a lot. If you pick up your phone, I can point out a bunch that have it. So that that alone is worth looking at the inventory. And then the user management is, just the stuff that it was difficult before, or, having multiple tables updated. You're maintaining your ERD. So when you have an entity relationship diagram and you need to do foreign key relationships, I know I said that, but we use batch before. Batch is optimistic. It'll get finished, but you don't have a guarantee window. Now we can do a batch that has a guarantee in isolation. And um, I, I say these things where like, that doesn't seem like a big trick, but man, here's the trick: is all this stuff happens at scale on a distributed system. And just keep in mind that, and this is the takeaway, all of these use cases have never been possible with Cassandra at the way that they do it, but also not possible with any other distributed database at the way that we do it. Cassandra the Accord protocol, and Cassandra enabled with the Accord protocol, is strictly serializable. That doesn't exist in any other distributed database. Not Spanner, not Cockroach, none of them. Not Aurora. There are no distributed databases that do strictly serializable ACID transactions across multiple data centers. We got that. That's ours. And we own it. It's part of our open source project, and we should be very proud of that. I am. So I'm going to walk through some developer use cases here. So if this isn't new to you, I'm sorry if this is a repeat, but it's always worth repeating. But this is just more of an update for you. Like, if you don't know, you haven't ever seen the transaction syntax, this is for you. And I think you'll find that it's different, but pretty useful. And there's a couple of things that I'm going to go through. Here's another Google image, by the way. This is a robot banker. That actually looked pretty good. But wait, it gets worse. So I'm going to do a quick walkthrough of like, what would a bank transaction look like with ACID transactions in Cassandra? So I have this classic, moving money from Bob to Alice, Alice to Bob. And so I have an account table where I have the holder and the balance, and I put 100 whatevers in each one of their accounts. So think about like how you would do this with Cassandra today without ACID transactions. There are ways you can do this that create reliability, but you can't do it in one shot. It will be in multiple shots. And so let me show you how it works. So here's how a transaction would work. So a transaction in Cassandra is bumpered by begin and commit. Inside that begin, we have this let. Now, I've gotten a lot of questions about this. What this let does, it allows you to collect state inside of the transaction from the cluster. And it creates a tuple. So this let from balance will be a tuple. In this case, it'll just have account balance. And so this is useful for the important part of doing decision making, the conditional block. That's one of the unique and cool things about a Cassandra transaction, is that it has a condition block, and it opens up a ton of use cases. But this is collecting information inside the transaction window from the running cluster. And then what we do is we also can change it. We can show we can have it display. And this is a little more confusing and probably worth discussing if you don't like it. It will display the user's balance before we did the transaction. So after you run this transaction, it'll show you what it was. The intent is that if you told it to change it told you to change it, then you need to know what it was before. So just in case, you need to do some auditing or anything. So it was 100 before, and I just changed it to -20. So it's now 80. I think and then this is where there's some room for growth in here. And this is something we've discussed, is there's also like, I would like to know that this actually happened to like a true, or it actually, the conditional fired off. We'll get to the conditional now. So the conditional, like I said, this is the true power of Cassandra ACID transactions. And this is all happening inside of an isolated block. And it's highly contended. It will work against a highly contended workload. So think about, like I use in my inventory example of like, hey, what about like everyone wants a PlayStation and they're clicking on buy it now, and you only have 100 of them in stock. That's a classic retail problem, right? This should be able to deal with it just fine. And think of what else you could do with that. But what's going on inside this if block is really cool. So we do have a condition. We can check for, we're checking that that tuple, so the from balance, account balance. If it's greater than 20, because I'm going to move $20 over, 20 bongo bucks, then meaning that there's actually money in Alice's account, then I do 2 updates. I batch up my updates, and these both happen in the transaction. And then again, it happens or it doesn't, and it's isolated and atomic, so that when the change happens, everyone in the cluster sees the switch in the data. There's no dirty reads or anything in the middle of this. So I'm also, this is the other, there's 2 things that I love about this. We just made update 1,000 times more useful. So this has not been a usable thing. We can't do an update account balance minus equal. I use a decrementer on an update. And when I show people this, a lot of people are like, can't you do that with an update now? No, you cannot. And this is new syntax, but it allows you to do an increment, decrement. This pretty much kills counters, by the way. Counters, your days are numbered. And because you don't have to think about in terms of like, well, these are eventually consistent or they're not a CRDT. No, you're doing an atomic count, and you could increment it, you could decrement it, you could set it, you could do whatever you want. So counters rip. Sorry, you had a good life. But so I'm taking 20 from Alice, I'm giving 20 to Bob, and commit the transaction. That all happens again in a highly contended workload, and poof, now Bob has 20 more bucks, Alice has 20 less. Think about that what could you do with this in multi data centers, in a 500 node cluster, in the most highly contended workloads that you have at Cassandra scale? This is why Accord was built, is because we've had a lot of this discussions for years. Like when Spanner came out, we're like, oh, maybe we should go with the Spanner protocol. Spanner sucks. It was good for back in the day, but Spanner is basically 2 Paxos domains that have a 2-phase commit between them. That's why it's so slow to do a write, because it has to do a 2-phase commit across multiple data centers. I don't care how many atomic clocks you have. That's still a slow transaction. So we rejected Spanner, and there's a few others that we rejected along the way. This is why Accord exists today, because it works the way Cassandra works. All right, I'm going to stop there. That's for the developers, and we're going to move over to the operators. There's a few things to think about as an operator. So your life may get a little more difficult, or just a little more. You have a little more work to do if you're doing an upgrade. If you're doing a clean install, just a brand new cluster and running ACID transactions out of that, most of this doesn't even apply. I'll talk about what it is. So we have a couple of things. So single key transactions, this thing right here, where you have a Paxos domain, and it does, it has 2 replicas, a primary and 2 replicas. It does the preps, it does the promise, accept, act, and then it does a commit. That check and set is what we've had already in Paxos. And like I said, Paxos V2 is what we're all working with right now. Yay team. Accord is multi-key transactions. So there's a lot going on here that requires multiple primaries, multiple replicas, and that's a different kind of transaction completely. And so when we enable our cluster, this is what you're enabling, is these multi-primary transactions. So there's only one thing that you absolutely, the mandatory thing, and the purple line at the top is the only thing you have to set inside of your YAML file, and that's Accord enabled true. I want you to set that, and if you're using my Docker image, it's already set for you. You're ready to go. There are optional areas, and there's some docs out there. There's actually a nice doc and an MD file in Trunk right now that goes through all of this stuff, but essentially, these are just a configuration. Like there's a journal directory. So as things are written, there's a journal. More like performance oriented, like how many Q shard counts and recovering delay and things like that. Fast path update delay. These are like your commit timeouts, things like that. Default transactional mode, I'll go into that in a minute. Right now it's set to auto. That's the default. But we have some choices there. And here's the one that just cracks me up. I said, create an image for me that demonstrates the power and safety of ACID transactions. And so it created an umbrella to cover my cake. This is great. I'm like, well, who wants wet cake? Not me. Thanks, ACID transactions. You saved my cake. Sorry, I have way too much fun with AI. Yeah. All right. So I feel like this slide deserves all the love it's going to get. So when we enable transact table or enable ACID, we have to give it to the table. So this is you don't just get it on every single table, no matter what. And that's a good thing because you don't want all these transactions. You don't want like a full transaction on everything. Welcome to the ultimate configurable Cassandra. Everything is choice. Like you want to do a RF of 1, go for it. You want to do RF of 3, go for it. But you have to turn on the ACID transactions per table. So in this case, you can create table with transactional mode equal full, and there are many choices of what those could be. I don't know if I go through that too much. So yeah, there's the transactional mode can be off, mix reads, or full. And the mix reads and off, well, off obviously means we're no longer doing transactions. Mix reads, that's a more advanced topic. We won't get into that too much. Just assume that you're going to use full because you want to have transactions. Yeah, so there, yeah, I did have the slide. Sometimes I don't remember how many slides I have, but I could do an alter table and change it. So this would be if you're migrating your existing data, like your data model, you can do an alter table and upgrade it with this. However, we now start getting into this migration world. If you're doing an alter table, if you're changing a table to be a transactional table, there's a little bit of work to do here. And the work is, so we have, let's see if I have all on the list. Yes. So there's some node tool commands to know. So if you go into node tool and you do a consensus admin, yes, there's a new node tool command called consensus admin. It'll show like, hey, here's all of the running or the tables that will be migrating. And you can do a begin migration, you do a repair, and then yeah, there's I don't know if you've know this, but there's a Paxos repair. Now there's an Accord repair as well. So you can do Paxos only and Paxos repair. And then once you finish that, you can, or when you say finish migration, that will make that table now transactional. You can see why I say you should probably run this on a greenfield to start with, because this is a bit of a process here, and we'll do better. I mean, we're going to do some probably enablement and everything around how to do this, but just know that there's quite a few steps, and it's on the command line. You have to use node tool. And the big one is that you have to be running Paxos v2. If you're going to 4 to 5, or you're running 4.1, you have to upgrade. This is in the YAML file. You say Paxos variant v2, and you can restart your cluster and do a Paxos repair, and it will bring everything up to Paxos v2. That's important though. So when you set a table to transactional full, non-transactional reads are just normal. You whatever consistency level you have, you can do quorum 1, whatever. Those will all play out the same way. It doesn't automatically make everything an ACID transaction. You have to go through, use the begin and end transaction to get that. So the other thing is that the writes will go through Accord for any migrating ranges, because it has to know where things are. So that's a little bit of a change. So if you're like add new nodes or anything like that, then Accord will have to be involved, because it has to have a very clear picture of where all the primary keys are, for the reasons we mentioned before. This is a multi-primary key transactional protocol. It has to be aware, have situational awareness of where everything is in the cluster. This is where TCM comes in. TCM, when you add a new node with TCM, it's instantaneous. That's one of the cool things about TCM, is no longer do we have this guidance where you have to wait a few minutes between each node. I think this is going to be very freeing. I can't wait for someone to add 100 nodes instantaneously to their cluster. And I can tell you from a DataStax standpoint, we are really excited about that because we use a lot of etcd to kind of control things inside of a cord when we do up and down scaling, grow and shrink node counts and things like that. But TCM is going to make it really easy for you to go up and down, so easy because it's just now my cluster is 20 nodes instead of 30. Very easy. So if you have a choice to migrate back, and this is just understanding like all the interactions with the table. So you can do migrations from alter table and bring your transactional mode to off. And then when you do that, you'll have to go back and do the node tool commands again. So you have to say the admin list, and then so you can go back, begin migration back to Paxos, do a repair over the cord only, and then consensus admin, finish migration, that sort of thing. You just reversing the process, but you're using a Paxos repair in this case. So you have to be running Paxos v2 though when you do this. So I'm giving you a lot of information for operators. If you run a cluster, let's work together on making sure we have a really clear piece of documentation for this. And I'd love some volunteers to help, create a Google Doc, like, hey, here's my run book or something like that. This is a slide. It's not a run book. So some best practices around operating Cassandra, or with especially what I've talked about with the operations. These regular repairs are really important because node ranges are very important, and where keys are very important. So that's the thing that we have to keep in mind, is that you need to have a clear picture of your cluster for the best, cleanest transactions, because every key is sacred. This token aware driver thing, I didn't realize this, and I was looking through the docs and I found this. They reduced this key. I mean, I didn't realize that that's happened, but token aware drivers do reduce that or repair overhead. And I guess it makes sense, because what you're essentially doing is you're not putting the coordinator in charge of doing the eventual consistency. You're just writing directly to the primary replicas or the token aware driver. So you limit the amount of exposure to potential shenanigans. I think that's what that means. And I hadn't really thought about it up to this point. And when I saw that in the doc, I was like, oh, yeah, that makes total sense. So, and now that we have more choices when it comes to consistency level, we just need to be more aware. If you have a transactional table, okay, great. And that transactional table that we have is going to be, I think this is the important thing, is like the transactional table adds one more step in our admin, and just making sure that we're keeping things straight there is a really good idea. Okay. That's all I had. I know this is a quick flyby, but I hope this was helpful. You can follow me on LinkedIn if you want. It's just my QR code. Questions?
QR code. Yes. Yeah.
Actually, don't follow me. Connect.
Thank you.
Yeah, thank you, Patrick.
Patrick, how much of this stuff is also, I'm guessing all of it's the SAI stuff, which then also affects the vector indexes? Or how does that stand in terms of the transactional perspective?
That's a good question. SAI, it shouldn't affect it at all, because it's still, and I'm just kind of, I don't have a off the book answer. I'm just thinking through this logically. A write is a write, and a write that goes to a mem table and gets flushed to an SS table that's an index will still go through the SAA path. So it shouldn't affect your indexing at all. Now, I know that the reads, this is something I have been reading about. The reads, you can do SAI reads inside of an ACID transaction. You can do a vector search inside of an ACID transaction. Everything
That's
is
what
legal.
excites me.
Yeah, I see where you're going. Okay, yeah. So reads are totally legal. I mean, if a select is a parsable, queryable select, game on. There's no restrictions.
Cool. Very cool. When are we getting stored procedures? I'm just kidding. I'm just kidding.
You know, those existed, right? Those exist actually.
No, but
you
now
can
I'm
create
talking
stored
about the
procedures.
type of stored procedures that, like, you know, like what we can do with transactions enables so much more.
All right. You're getting it. So, Mr. OLAP, this is not that transaction. These are not interactive transactions. These
Yeah.
are, So, but when are we going to do that? As soon as we have a redo log and,
Right.
query planner.
Well, you know, everybody eventually needs a query planner and a query optimizer.
It's a CEP. We do have that CEP out there if you'd like to pile on. Cost-based optimizer is, I believe, the query planner. Cost-based optimizer, one of the two. But there's a CEP out there for this right now.
Nice. I think unrelated question, but Patrick, are you using anything like Cursor or Claude and Cloud Code on the stuff that you work on?
Oh, I've been pretty much exclusive on Cursor for a while now. Yeah, I love Cursor. Yeah.
Is it helping in the Cassandra work, like the actual, you know, code base, or do you generally use it on code talking to Cassandra?
Code talking to Cassandra. I used it. I actually used a bit of AI, pretty specifically on the grammar for Cassandra when I was working through the as syntax. I had to do some validation for me. I was like, you know, it's like, is this correct? And the problem is we use Antler 3, not Antler 4. So, which is ancient. And so, but I mean, the grammar is, you know, it's a pretty standard grammar. So, yeah, and it helped me make sure that I got that right, which was very helpful because no one's an expert at regular expressions or grammars. If you are, you're awesome. Yeah.
Thank you very much.
Yeah. Hey, there's
Yeah,
Johnny.
we also have some questions on the chat. Yeah.
And I've been keeping Johnny busy on his workbench. He just added Astra support. Thanks, Johnny.
Well, I think I'm going to put in. I think I'll pull in something to get your kind of early Accord Docker images deploying local clusters, so people can have a quick play. Shouldn't take too long.
Oh, excellent! See, this is teamwork. I love that.
I can get that in. I won't have the enhanced console bits, but I'll use your SQL SH to try and get people playing with it and using it. Shouldn't take.
Fantastic. Yeah.
There are a few questions in the chat now. So there's a question: QR code links to the Cloud Native book, correct? And then yes, that's yes. Are there any recommendations for, where did it go? Oh, there's a couple of questions. So Hill, can you read the first one? I just lost it.
Yeah, I can start from the top, and it says, can we use CCM to try Accord? Thanks.
Yes, that's an easy yes. Because I mean, because CCM works with, I mean, anything. If you use CCM, you know, you can use it on a branch, you can use it on a specific, you know, commit SHA. So it's pretty flexible. You just use CCM against trunk and it will create the cluster for you. The thing that you probably need to make sure that you enable is you have to enable that feature. You have to turn Accord on in the YAML, and that's I think there's a syntax where you can add things to the Cassandra YAML. Just make sure that you enable Accord.
Yeah. And next one, are there any recommendations heap-wise when turning on these transactions?
I think the standard I mean, it's the thing you need to know is that this trunk is running on JDK 17, so you have choices. And the choices are you can use Shenandoah, ZGC. You can get your heap much bigger. There's I know it's not a good idea to lump up or to pile on different changes, but you have choices. And the JDK 17 is pretty amazing when it runs Cassandra anyway. JDK 21 is even more amazing, but yeah, I think you just go with the standard heap sizing. We don't have any specific guidance, and this is up to you. If you find something that doesn't work right or you have a different point of view, let us know.
Right, thank you. And the next one is I was thinking high number of transaction was incompatible with scalability. Is this changed now?
Um, no, well, it's meant to be a highly contended, it's meant to manage highly contended workloads. So this is something that was like top of the list because this is the holy grail. You got to have that, right? Yes, it's not, there's no free lunch. A Paxos transaction, for instance, requires a couple of round trips now with V2. We think the guess is that we can get ask transactions to around 1 or 2 round trips. So yes, it's not the same as doing a CL of 1. CL of 1 is always going to be the fastest because it just is YOLOing your code into your mutation into the cluster. But the intent is to make it not a huge amount of overhead, especially with multi-data center. That round trip of one round trip on multi-data center is the goal.
Awesome, thank you. And I think that was the last question there. And thank you, Patrick, for your great presentation. And I'm just gonna say that this is recorded and the recording will be available at Planet Cassandra YouTube. And we will have the next meetup in next month. And I make sure I will notify all of you. And I hope to see you all there. And
Great.
Is that all, Rahul?
Thank you. Thanks, Rahul.
Yeah, thank you, everybody.
See everyone on Slack. Remember that it's out there. All right. Thanks, everyone.
Thanks, everyone.